Welcome to Newline Guide to Building Apps with React Native. In this course, we're going to take a product-based development approach. What that means is, we will look at building a design system for the app and taking an atomic design pattern methodology for building UIs. React Native already black boxes out a lot of platform-specific nuances, so I feel the focus should be on building our apps as an experience. I recommend that the student build their own apps along with the course, as building something ready-made hides the nuances of a real app, though we will be building an e-commerce app over the span of the course, so students can choose to build that too. By the end of this course, you will not just be able to build a performant app in React Native, but also know how to troubleshoot bottlenecks. The course is split into 8 sections and a bonus content section. It will start by covering the fundamentals like navigation, setting up screens, styles, and UI elements, before moving on to more advanced topics such as state management, crash and error reporting, setting up analytics and middleware, debugging, and performance optimization. Now, the fundamentals discussed over the course can be applied to building any UI application and is not limited to React Native apps. If you have a question, you can ask in our Discord channel. You can find the link in the notes below. Feel free to hop on to the channel and ask your question. We will be sure to respond and help you out. We will be building the app using TypeScript, and the course comes with a boilerplate code which will help the students jumpstart. We hope you enjoy the course and it helps you build beautiful products with React Native. Hi, React Native for JavaScript Developers is a course designed for developers who have been working with JavaScript for a long time and want to understand how it serves as an excellent platform for building apps. We will start the course by covering the fundamentals like setting up the navigation, building the screens, adding styles, building UI elements, and then moving on to more advanced topics like state management, crash reporting, setting up the analytics using middlewares, debugging, and performance optimizations. Over the course of the module, we will be building an app using a boilerplate code, and like any other open source framework, React Native provides a wide range of tools and libraries to its users. We will cover the topics of the module using a set of tools that have been pre-baked into the boilerplate code. These tools are time-tested, and some of them are industry standards and are highly recommended, although developers are free to substitute any of these tools with a choice of their own. A word of caution here though, as some of these tools have a direct impact on the performance of the application. With React Native, the important part is to understand how these pieces come together to create an app. This course is not just designed for someone looking to jumpstart building apps using React Native, but we will take a product-based development approach and learn about things to take care of to achieve native performance on both the platforms, Android and iOS. This is the first module, Getting Started. We will look at some of the real-world apps that you might not have known to be on React Native. It's going to be a fun little exercise. We will talk about storyboarding and how it aligns to product-based app development and why it is a must if you go by my advice. Then towards the end, we will build and run the boilerplate code that comes along with the course. The bonus content section contains some of the libraries that deserve a special mention in the RN world. The first of them is Lottie. If you have not heard about it, do check it out. While it is mostly used for micro animations, I've had the experience of rendering some really complex animations with this without breaking a sweat. And the best part, these are not memory intensive, and I've seen them work amazingly on some pretty low-end configuration phones too. React Native SVG is the second one. While it does not draw a lot of attention like Lottie, but trust me, it is a lifesaver. Most of the images we ended up using were SVG. So what are the prerequisites? The course does not expect you to have any prior experience developing native apps. In fact, I was at the same place when I started off a few years ago. It is not a requirement for React Native. JavaScript is at the base of everything React Native, so that is a must. Knowledge of React is good to have, as fundamentally the concepts remain the same between React and React Native. Although I would say do not let that discourage you if you have the experience with any front-end framework before. The boilerplate code we are going to use over the course of this module is based on TypeScript. So if you have used TypeScript before, that is a plus. If not, we'll learn as we go. Although we'll be building an app as we progress through the course, I have planned the modules to be standalone as much as they could be, so that you can jump through the topics that you're comfortable with or come back to them later without requiring too much background. However, where required, I've added a heading called prerequisites at the top of the section about what other modules you need to complete so that you can better understand the current one. So if you do want to jump to any section, just remember to go through the prerequisites before you do that. Having said all of the above, I do recommend that you go through the modules of section 1, that's getting started, in the order, as this sort of build up to the type of learning we are trying to achieve here. And it also lays the foundation for this entire course. Broadly speaking, apps are categorized into 3 types. First comes our very familiar and the most popular two, what we like to call the native apps. Now, as the name suggests, these apps are built on native platforms like Java or Kotlin for Android and Objective-C or Swift for iOS. The SDKs and the IDEs for developing on these platforms are freely available from the OEMs themselves. Apple has Xcode and Android is built on Android Studio by Google. Then comes our PWAs, or the progressive web apps. Now typically these are websites that can be bookmarked to home screens of the respective platforms. They are made responsive to cater to the mobile device resolutions. And finally comes our hybrid types. Now frankly there are multiple options here. One option is to build a web application and run it inside a WebView container. These are built on web technologies like HTML, CSS, and JavaScript, and they render on web views. Ionic and Cordova are examples of such platforms. Another category is that of applications that render on the native views, providing some kind of a technology bridge that enables developers to do that without writing any native code. These are generally written in a common language, like JavaScript or Dust. Though when finally compiled and packed as apps, these run on native views, providing a first-class native experience, and are also deployable to multiple platforms, mostly promoted as write once, deploy multiple times platforms. React Native falls under this hybrid category of apps. So how does it differ from these other platforms? Now this is the important part. React Native renders everything on the UI thread of the app in native while handling the interactions on the JavaScript thread. So what does that mean? It means a React Native app will be responsive and deliver a native-like performance only if the JavaScript thread is well optimized. That is, in simple terms, kept free as much as possible for rendering. If that is confusing to you, don't worry about it just yet. This may sound like a lot, but as you go through the modules of this course, you will see that if you can just follow some thumb rules and best practices, along with an app architecture that clearly segregates responsibility, you will be amazed to the complexity of apps that you can build with React Native. Now the question that comes a lot across many forums too is it worth investing in React Native? After all, this is a wrapper above the native and can never be as fast, right? Well, I do not agree with that. I like to approach this question differently, and the answer as usual is not straightforward. The answer for me depends upon what are you looking to build for. If for a moment you could keep this perspective out of the head, that React Native apps have performance issues, and I believe they are mostly because they are poorly written, will it then make sense to build apps in React Native, or Flutter, or maybe even Xamarin? Remember, React Native renders everything in native, so it is not like a web view. The experience that end users of your app get is that of a first-class citizen. Let us do one small exercise which can help clear some of the bias towards not just React Native, but also towards other cross-platform tools like it. Let's look at these apps, some of which are in React Native obviously. Feel free to download these apps, use them for a minute, and then try guessing as to which category do they fall out of the above 3. So let's start with Discord. That's a pretty decent load time. Let's start loading more messages. A little more. As you can see, the transition between loading the messages and displaying them is not jerky. So let's scroll really fast. Seems to be doing a pretty good job. Let's go to the side menu. It's a list, and we have tabs at the bottom. So it seems to be performing pretty well, right? Okay. So next up is this Cars24 app. It's an app that allows you to buy and sell secondhand used cars. So as we saw, the loading time was pretty good, right? Let me just kill this whole thing and then start again. Yeah, pretty decent. It has a gallery to start with. Okay, that seems to be doing well. Okay, let me just log in to this and come back to the app. So it has a nice little animation going on right here, recent OTP. Login. Let's connect WhatsApp. Okay, later. So that was a pop-up. And it displays cars like this. So it's trying to render how many? 5 images. And the UI seems to be pretty heavy. That's a lot of cards. Let's try and load more cars to it and see how it performs. It seems to be pretty smooth. It has tabs at the bottom. We'll look at it in a few seconds. But let's look at how does it perform when we scroll really fast. Yeah, it seems to be doing a good job. Okay, so these are the other tabs, and there seems to be another list here. It's 29,000 at the top. So overall, seems to be doing a good job. I'm not going to try Facebook. I think we have all used that. So let's move on to Amazon. Okay, that's a pretty decent load time. We have all used Amazon too, I suppose. It has a home page of pretty fixed length, but it seems to be doing pretty well. If we scroll really fast, that's good. Let's move on to some other tab. And yeah, so Amazon is a very widely used app, although the UI doesn't really feel like native. But what do you say? Is it a native app? Is it a hybrid app? Is it a web view? What do you think? The transitions definitely seem native, but I'll let you guys decide. Okay, and at last, let's see Airbnb. That's a pretty decent launch time. Airbnb, I think, has one of the best user experiences, really nice transitions. Let's try and search for some place to go. I'm trying to be adventurous. Let's see, Iceland. What are you looking for? That was a really great transition, right? Finding a place to stay. Calendars. Let's do next. Adults to search. So it has a map at the top and a list of properties at the bottom. Let's try and load a lot of properties and see how it performs. Wow, it seems to be doing really good, right? That is nice. So let's move to the map view. And I'm just trying to zoom in, zoom out. Let's see what happens when you tap one of these. That was again a really nice transition. Airbnb does a really good job with that app, right? So these are the other tabs. I think the Explore tab is one of the heaviest ones, doing a lot of work. Okay. There are a couple more that I have mentioned in the course, like the Walmart grocery and Tableau, that I have not really tried here because they're not really available and you need accounts to do that. So feel free to download those and try it yourself. And if you're ready, let's look at the answers. Did that list surprise you? Airbnb, Facebook are native apps. Amazon is a hybrid app. And the rest of the apps that you saw or you even tried, like Discord, Walmart Grocery, Cars24, Shopify, Tableau, all of them are React Native apps. A disclaimer, Discord iOS is only on React Native. Discord Android is native. Facebook is native, although I think their marketplace tab is on React Native. Amazon is a hybrid app. To my best of my understanding, what they do is they launch web views and they use the native transitions to make it feel more like an app. So I hope that helps clear some of the bias around performance. It all depends on how good you write the app, how well the app is structured, and how you do really design the user experience of the app. Now, since we are at it, let's also talk about the elephant in the room, the Airbnb articles. There was a series of articles by Airbnb that became quite unpopular where they had called out on sunsetting React Native for their app. They had even published a detailed analysis in what was a 5-part series about the pros, cons, and their experience with it. Now, I would recommend reading those articles yourself, and I would also recommend that readers take those with a pinch of salt. Firstly, it was still 2016 when they started off with React Native. Also, they had not built the app on React Native, but were using it to build only parts of it, like a brownfield approach. So they relied heavily on the bridge for communicating and creating, which is, I wouldn't say the weakest, but comparatively the slowest link in React Native world. And to be fair, React Native was itself quite new at the time and had very frequent upgrades. React has come a long way since then, and React Native 2 has had some major upgrades, especially with the lean core, Hermes support, and the all-new one-stop debugger, Flipper. There is also a major re-architecture happening to how React Native interacts with native modules, where they're doing away with the bridge and substituting it with a new component called JSI, or the JavaScript interface. This element will also serve as an enabler for new Fabric and Turbo modules. With this new architecture, developers will be able to use any JavaScript engine and are not bound to JavaScript core. We will have direct control over native modules, and the application will use them only when required instead of starting all of them at the start. Then there is Fabric, which is a re-architecture of the UI manager and is expected to transform the rendering layer by eliminating the need in bridges. These are mostly under the hood transformations that are happening. Moving towards the end of the series of the Airbnb articles, part 4, it also mentions some interesting observations of an internal survey of its developers. 60% would describe their experience as amazing, and 63% of the engineers would have chosen React Native again given a chance, and 74% would consider React Native for a new project. I hope this little exercise helps clear some of the bias in the mind. Now, the idea is not to sell React Native, but I want the readers to approach this course with an open mind so that they can learn React Native the right way, and we'll see that React Native can deliver what we want to build with it. As I mentioned in the About the Course lesson earlier, I recommend a product-based development approach for building apps using React Native. Once you get a hang of the ecosystem around React Native, building apps will become the easy part. The tricky part is knowing how to set up a strong foundation that helps you build a maintainable and a scalable app the right way. Now, if we look at the app we want to build as a product that our end users are going to use, we will be able to build a great experience and not just an app. I mean, is that not the aim of using a cross-platform tool like React Native for app development? Okay, let's look at this objectively. Using React Native, we are reusing our expertise in JavaScript or TypeScript, right? We are black boxing out most of the platform-specific nuances and trying to build ones and deploy on multiple platforms. We are looking to iterate furiously and reduce the time to production. And with all of this, provide a consistent experience across platforms to our end users. So if you look at all the above points, we have offloaded quite a few nuances of building apps to the platform and are trying to play on our strengths. So wouldn't focusing on building our app as a product make the most sense? And having a clear view of what we are looking to build will not just help us get there, but also help us not get lost in technicalities and challenges of our platform. Storyboarding the app will help us achieve just that. By definition, a storyboard is a visual representation of a film sequence and breaks down the action into individual panels. It sketches out how a video will unfold shot by shot. This is not the typical storyboarding that is created by the design teams, though the idea is similar to that, as it is a very good way of looking at our app from a technical implementation point of view. Here, we will create a wireframe design of the app we are looking to build. The goal of this step is multifold. First, it will help lay out the navigation flow of the app. This will help us lay the foundation of the app. Do we want a single screen stacked app with a side menu, Or do we need to have a tab navigation? Next, it will help identify the structure of the views. The app design may have a common header. So can we build a fixed header that can be shared across screens? Then we'll look to build a design system, and we'll use the atomic design pattern to do that. Now there is a whole module dedicated to this process, so we'll cover that in details there. But in short, a design system will help us build a prototype for the app, like standardizing the most basic elements, defining the primary and secondary colors, defining paddings, margins, headers, titles, basically every part of the app. Next, as a part of the design system, we will also identify elements and components. Elements are the most basic building blocks that are used to build any view, like text boxes, buttons, and along with design, we'll also define their behavior. Components are the building blocks. Think of them as Lego blocks. For example, a view may have a carousel, product displays, reviews and rating cards. The idea is to break the UI down into individual reusable components. The process also helps us build consistency across the app and in turn reduce cognitive load on our users of the app. I would recommend building custom elements for even most basic native ones like text element or image. What this does is it makes the app very maintainable. Say for example, the design tomorrow changes to support a new font for the app. Now, if we have a custom element for text, doing that is practically a one-line change in the application's design system. Another example can be about changing the brand colors or the theme of the application that includes default fonts or maybe supporting the dark mode. Storyboarding and a design system will help us achieve all of this. Let's look at the screens right in front of us. For example, what do we have here? We have an initial tour, a few screens that are trying to show what the app is going to do for them, for our users, and then it lands on a home page. Now, from a technical standpoint, let's see how we can break this entire flow down into elements and components. So first, there's this screen. We have a carousel here that supports displaying multiple images, and the user can navigate forward and backwards through it. So this kind of gives the tour. So this is a carousel. Then we have our very basic elements, buttons that helps the user to navigate, and finally land on the home page using this home button that can be a primary button made of the brand color of the app. When we land on the home page, let's see what we have. We have a search bar at the top, a set of category icons, then there is a carousel again, but this time a product carousel, and then probably a banner carousel and with the tab navigation at the bottom. So as we can see, we have a product carousel over here. So probably this can be reused from what we built for the initial tour. The difference being out here, our carousel was supporting a set of images. And out here, it's supporting a set of product cards. So these can be different type of components for a carousel that we build for this application, right? And we can reuse what we build here out here. Similarly, it can be done for the banner carousel. This time again, a set of images. The difference being this probably is a free-flowing one. And again, even for the category icons, if they extend beyond the viewpoint, then this one again can be a carousel, but this time we'll pass category icons as children. At the top, we have the search bar. So it consists of the most basic text element that supports displaying an icon, and it'll depend upon the implementation of the search bar. Is it going to be a drop-down list over here, or it's going to be a separate screen? So if we look at the whole thing holistically from a storyboarding point of view, just these three screens from the user opening the app to landing on the home page, we have broken this down into a swiper, a set of secondary buttons that can be defined with typography, There's a primary button that takes us to the home page. Then on the home page, we have category icons, a product carousel, again a primary button, but displaying a different text and a different action, but still a primary button, a banner carousel, and a header. How much of this are we able to reuse just between these three screens? A lot, right? And how much can we standardize using a design system? As we move forward in the journey of storyboarding to the further screens, the number of new elements and styles and typography that we defined is going to reduce. And it should reduce. Otherwise, we need to check, are we building a consistent app, or are we building an app where each screen has its own identity and doesn't fall in line with an overall brand image or a brand colors or a brand picture? For the purpose of the course, we'll use an open source boilerplate. It has been based off the official React Native Getting Started guide, and TypeScript integration is done using instructions from Microsoft's TypeScript React Native Starter repo on GitHub. Now, the default way of creating a new app in React Native is either using Expo or the React Native CLI. The boilerplate code is built using React Native CLI plus TypeScript integration and a few other tools that are required in any app. So let's look at what the boilerplate code has to offer. The routing and navigation has been done using React Native Navigation. We'll see more details of this in upcoming modules. For state management, we are following the Flux architecture. Flux really helps control the data flow of the application and manage it at scale. Redux is the library that implements this pattern, and we'll be using the same. We'll also integrate Thunk for side effect handling. The boilerplate code also has basic setup done for typography, some global styles for building elements and widgets. These will help in defining a design system for the app. And it also has code lint using Airbnb's linting. Now these tools can be replaced as per developer's choice. So next, let's look at the project structure before we jump into running the code. The project is based off React Native CLI. So the structure that we see here is actually quite similar to that. Now there are four major folders: Android, iOS, Shared, and SRC. Android and iOS are the native folders, while Shared and SRC are the folders that will work mostly on to build the React Native app. Now the native folders are only required if we want to make some changes to the native side, or if we want to run code from Android Studio or maybe from Xcode. Apart from that, in Android folder, we can find our APKs that we'll build. So it will be under Android, app, build, output, APK, and then debug. So we'll have the APKs here. So it'll be either a debug folder or a release folder based on the kind of app that we have built. These APKs are installable. We can drop them on simulators and install them, or we could also transfer them as files and then install them on our phones. So that's about the Android folder. For iOS, unfortunately, there is no such way to build files and then install them. They have to be done either through TestFlight or some other tool like Fastlane or maybe Firebase. Now, if you want to open the iOS project, remember to open the appname.xc workspace file. Do not open the appname.xcode project file. That will not work. So remember, you have to open the xc workspace file. We'll see how to run apps from the Android and iOS folder in the next lesson. The shared folder is where we have all the business logic of the application, and the SRC folder contains everything related to the presentation. In the shared folder, we have our Redux and our services. We look at Redux in detail in the state management lesson that we have in this course. The folders action, reducers, and store are actually a part of it. In action, we have all the actions of the app. We define all of them. App.ts has global actions for the app. As we keep building different screens like home screen or card screen or something else, we'll keep adding to it. The constants has all the constant types. We'll build objects to access strings. We'll never use hard-coded strings in the application. Reducers has index.txx. It combines all the reducers of the app at a single place for the store to consume. Uh, the app.tsx actually implements the action that we defined under actions, that is the splash launched. And similar to what we do for actions, we will also keep building different files for different reducers, and that we go forward in the as we go forward in the app. Store, this is where we actually initialize our store and we add all the middlewares. As you can see, we are actually adding the logger middleware and the thunk middleware. Yeah, it's there. We have added the logger inside an if block. Now this variable is exposed by React Native, and this code will only get executed in the dev mode. In the release mode, it's not executed. So it's a good place to add the logger, as we don't need the logger in production mode. Now finally, we pass the reducers and all the middlewares to it, to the store, to create the store, and we export it. So if we need any other middleware like analytics we may require, we can add them here. So thunks are basically action creators. They are great for side effect handling. Whenever a view fires an action, thunk is the place where we need to implement all the business logic. If we need to make an API call, if we need to store some data in application storage like async storage or SQLite, or something very simple like storing it in memory or fetching something, this is the place that we need to do it. Services folder is quite simple. We'll have all the different services here like analytics or making API call to the backend for card or for any part that your application requires. Now the core folder is what I like to maintain as a low level implementation. So we have storage.ts, and similarly we can have maybe an api.ts, and let's say that we want to use fetch for implementing APIs, or we want to use Axios or API source. Now this is where I would go ahead and make those implementations, like for get calls, post calls and everything. And I'll expose very simple methods to the rest of the services. Now the reason for that is tomorrow, let's say we want to change from Axios to API source or to something else, or we want to change the storage from async storage to SQLite, or again iCloud or something else. So this kind of abstraction really helps out for a long-term maintainability, as the services don't really care whether you're using, what kind of technology are you using at the backend to make those calls really. Next, let's look at the SRC folder. So this one contains everything related to the presentation of the app, the screens, the views, the styles and everything else. Now config is basically the config that your application boots with. It can be all the APIs that your app will need to make calls to, the base URL, the default locale in case your app supports multiple locales, and if a user has not selected locale up till now, then what's the default locale that's supposed to come. So basically this keeps growing as the app grows. Constants are again very similar to the action types we had. So all the screen names are basically strings, so we just try to define constants for those to be used across the app. In navigators, we have index.tsx. This is where the application boots from. It listens for a particular event. Now this is how it works in React Native. And then we can set some default options like, do we want the top bar visible? And there are a lot of other things we can do. And then we tell the app how to boot the application with, as in, do we want to boot with a stacked application, a single screen with a side menu, or do we want to use a tab navigation? Next is our navigation.tsx. So this is where we define the base navigation of the app, like the stacked app versus tab navigation. And then we have our router.tsx. So router.tsx has all the methods that we will call in response to user actions that are performed in our applications. So for clarity, I just like to separate them out as navigations and routers. As we can see, router would be let's say show cart screen, or maybe show modal or something like that, or maybe go back to some screen, right? Or pop to root. Pop to root is basically if we have opened 4 or 5 different screens, then going back to the base screen. So router is basically more towards routing logic. Next, let's look at the view folder. So this one has assets, elements, screens, styles, and widgets. So assets are all the SVGs and PNGs that we are going to use across the application. Uh, Screens are all the different views that we will have. Styles is where we'll define the global typography of the application. Now, global.tsx is the global. We'll talk about building a design system in the application, which really helps in maintainability and consistency of the app. Now, global.tsx and typography, these two are play a very critical part in building that. So globals has default settings for some of the styling of the app, like what should be the page margin, what should be the header size, what should be the title size, what should be the button fonts, colors, and these types of things. Typography is our application's let's say color palette. We can call it color palette or theme. So it has a few things like colors, fonts. So we define the colors over here. Like I said, we don't want 10 developers to be putting in 5 different blues in the applications. A blue that is our brand color. We'll simply declare them here and reuse them across the application. So this will work as a typography. And we'll also declare the fonts over here. So let's say tomorrow we want to change the font from Helvetica to something else, to sans serif or Comic Sans. All we need to do is we need to come and make the changes over here, and it should reflect throughout the entire application. Now, I left the elements part on purpose as it plays a critical role in building the design system, the elements and the widgets. We'll look at them in detail in our design system lesson, but in short, elements would be our most native building blocks of the application, like buttons and text boxes. We'll also style them using the typography and the global styles that we have defined, so that we can really build consistent components across the application. Widgets will be our components. So these will be like headers, like carousels, product widgets, and all the different components that will be required to build any particular view or screen on the application. That was the structure of the application. Next, let's look at the flow of code. So index.js is the entry point of the application. It's calling an app function which is inside our navigator. Now our navigator is listening for a registered app launch event, and once that is done, it will set some default options like about the top bar. Do we want it to be visible or not? What theme should it be? And then it sets the kind of application we're looking to build. So the show splash method over here, it's trying to do a stacked app with a side menu. Now, if we wanted to do a tab navigation, we have already defined that here. All we needed to do was call that particular method instead of the show splash method, and our application will boot up with a tab navigation. Now, apart from that, we are registering all the screens over here before the app launches. So if we build a new screen, they have to be registered over here, and we have written a very thin wrapper since we are using Redux as state management, and all it does is it adds the provider. This is very similar to what we do in Redux, and it passes the store to those screens. Now, once the app is launched and the control is moved to, let's say, the splash method over here, it basically calls the splash screen. Let's go there, and it tries to render the splash component that we have over here. So let's look at any particular screen. This is basically broken into 3 parts. One is the component.tsx. So this is basically the entire component that we define. It can be a class, it can be a functional component. Next is an index.tsx. We are defining our map state to props and map dispatch to props over here. It's very similar to React. So basically what a map state to props does is we would use it to provide the store data to our components, like the splash page over here, splash screen over here, whereas the map dispatch to props is something that we will use to provide action creators. So any actions that we dispatch will be declared over here, and from here we'll call the methods from the thunks that we had defined earlier. And the next is styles.txx. This is again very simple. It contains all the styles for a particular screen. Now we saw a styles folder earlier. Just remember the difference, that the folder that we saw earlier, which had global and typography, are styles that will be reused across the application, and they should be referenced like over here as much as possible, but we will need styles for individual screens, and it's best to keep them along with the screens. It's just easier in development mode to have the styles along with the screens while we're building them, but you can definitely choose to keep all the styles together. So that's the entire flow of the app, and it has all the basics that are required for building an app using React Native, and it also has TypeScript, so it doesn't have anything additional as of now, only React Native navigation. So if we'll go to the package.json and we'll look at dependencies, so it only has Redux for state management, and it has React Native navigation. Apart from that, the package.json has a few scripts that are helpful. Like we have the command for building the Android app in debug mode or in release mode, or we want to start the Android through our terminal. So we just need to do React Native run Android, the variant over here, and this is the device ID that the emulator, the ID of the emulator that needs to be in your system. Just change it and use what you have in your system. And very similarly for iOS. Okay, so let's jump into some coding. In this module, we'll build the boilerplate code that we talked about in the previous lesson, and we'll run it using Xcode and Android, and we'll also run it using terminal. There's no specific benefit of using either. It's just that people tend to have preferences, and all of them work fine. So let's get started. The first step is to clone the repository. We could also download a zip from the boilerplate GitHub repo. We'll be cloning the repo. So let's do that. Next, let's get inside the repository, and if we follow the instructions, it says we need to do yarn install or npm install. So let's do that. This is a command. Just remember this. Every time we do development, we have to start the Metro bundler, and the command for that is yarn start. So as a first step, we'll try to run this on iOS, and we'll need Xcode for that. So let's launch Xcode. And then we need to go into the iOS folder. Remember, the application has iOS and Android folders at the root location. So just go into the iOS folder and do pod install. This is the one-time step. So let's just go to the iOS folder and do pod install. And then we need to open Xcode and simply run the project from there. Now let's look at a few things while we are here. So this is your Xcode interface. We'll not need much of it unless you want to run your React Native applications through Xcode. It's totally a personal preference. This is basically the project, and if you want to change your simulators, you can do it from here. If you want to add any additional simulators, we can do it from here. Then if you connect a real device through USB, that will also show up over here. It says no devices connected, but if you connect, it will show up over here. So let's see if our pods are installed. Yes, they have. So we'll just build the project. Now doing this for the first time will take some time to get this done. So once the project is built, let us continue from there. Okay, so I'm back. The project is built. Let's just run it, and it should open the simulator. While that happens, let's also start our bundler. Remember, we need to start the bundler before the project starts on the simulator. As we can see here, the bundler has started, and we can press R anytime to reload the app, and we can press D for the developer menu that helps in debugging the entire app. We'll go over what are the different debugging options in React Native in one of the later modules. We'll cover it extensively. Again, there are multiple choices and not one answer. Now, as we can see, it was trying to load the bundle, and it has loaded. So there we have our app. This is the initial splash screen. If you want to reload the app, just press R twice once the simulator is selected, and it will reload the app. So let's continue to the application, and we have our home screen. So this is the tab-based navigation, and we have two screens over here. So let's try and make a small change and see how the live reload works. So this is the splash component, and we have the button that's called continue to app. Let's just say, let's call it just continue and save, and that should reflect immediately. That was quite fast, right? Yeah. So next, let's look at the same using Android Studio. So in case you run into any issues with iOS or Android setups, I've tried to add the common errors over here. Like for iOS, one of the most common ones is pod not found. That means you don't have Cocoa pods installed in your system. So just follow the steps for that. And remember to do pod install. That's just one additional step that's required for iOS. For Android, the initial steps are the same. We clone the repo, we do npm install, and from there, let's do it from the Android Studio. So it's quite similar to how we run code with Xcode. We just build the code and run it. We can keep the bundler running, as it will also be required with Android. So we have our Xcode Android Studio, and all we need to do is just press this run button. The app is already selected. Now remember to load the Android folder from the project, as we can see here at the root, the Android folder. So that needs to be loaded in Android Studio, and all we need to do is press run, and it should start the simulator that we had selected over here. It's quite similar again to Xcode, and we have our devices here. And once we connect a real device using USB, it will start showing up here. Now, one additional thing, once you connect a real device, sometimes it might not show up. The reason for that is we need to enable USB debugging. So it took some time to build the app for Android Studio and install it. It does that automatically and launch. So I've skipped that part, but it's pretty much the same. Just press the run button and it should work. And we can see a very similar experience. So let's check the live reload over here. Let's again change the text to continue, and it should reflect in the app. And it says refreshing, and there we have it. So yeah, pretty much the same, right? So again, for Android too, I have added the common errors here. So next, let's look at doing the same thing using CLI. I find that to be the most the most preferred option that I use, because I don't have to launch Android Studios and Xcodes. Because working on React Native, we practically don't need to do anything there, and they take up a lot of memory. So using CLI is also quite straightforward. If we move to the iOS section, using the terminal, all we need to do is we need to run this particular command, React Native run iOS. For Android, it's run Android, and then we pass in the simulator name. So let's just do that. We need to have the bundler running. So I'll just open a new tab at the root location, remember, and just run the command. Now remember this, the name of the simulator that we pass in, that should exist in our system, otherwise this command won't work. So just check for that. Now one way to find the simulators installed in your system is by running a very simple command, xrun simctl list, and it will give you all the simulators that are installed. So here I picked iPhone 11, and the first time this command may take time. And remember, we are running the code using CLI, but that doesn't mean that we don't need Xcode installed in the system. We do need Xcode in the system, so do install that and update it. And as a check, just run Xcode once. What I'm saying is we don't need to run the code using Xcode once, but just run it, launch the Xcode application once. The first time we launch Xcode, we'll try to install additional tools that are required to run these commands and build build Mac app and iOS apps using CLI. So that is required. So there we have. And so this is also a preferred way. You can simply run one command from the terminal and it works. Let's try the same for Android. So it's quite similar for Android. The command just varies a little. We again have our React Native and then run Android. Now here we have a variant if you want to run in debug mode or in release mode. And instead of simulator, we are saying device ID. This is again a device ID, and it's a simulator that needs to be installed on your system again. And one way to find it is using this command. It will list down all the simulators in your system. So let's try and run this command. The one difference between Android and iOS using CLI is that when we launched the command for iOS, it launched the simulator, installed the app, and then kickstarted the app. In Android, we have to launch the simulator separately and then run this particular command. So let's run the simulator first. The command for that is quite similar to this one. So it's basically going to the emulator folder and then -avd and then the device name. So that should start the simulator for us. Next, let's copy the command. We don't need to copy the device ID because we only have one simulator running. So it will automatically install our app in that and launch it. It's quite similar to iOS, except that one extra step of launching the simulator first. So again, building this for the first time, it will take a little longer. So let me just jump to that. And I'm back. It does take a little bit of time the first time we do it, though this is all also a lot dependent on the kind of machine that we are running. We just saw the different ways of running the app, either through Xcode or Android or terminal. To summarize, if you want to use Xcode, just open the appname.xeosis project in the Xcode and run it. Don't forget to start your Metro bundler. For Android, just open the Android folder and run it. Again, quite simple. For CLI, start the Metro bundler, and for iOS, just run a single command that we can find here. And for Android, run the simulator first and then run this command. As I said earlier, through the rest of the course, we'll be building an e-commerce app. Now, we'll not be building the entire app, but major parts of it, like the home page, the PDP, and a little bit of cart. And I'll leave the rest to the students to complete, as we would have covered most of the aspects of building app using React Native. The important part is to understand how these pieces fit together. And it's not just about extending our JavaScript expertise. Now that's an obvious goal, but it's also about how do you build an app? How do you start from a blank slate and take the journey of building a production app? As I like to call it, from storyboarding to production. And with that goal in mind, I'll see you in the next module. We'll be using React Native navigation to build our app. There are a few other solutions available too, and also very popular, like React navigation is one of them. Though from my experience, I recommend React Native Navigation as it provides a 100% native navigation on both the platforms. So what that means is it doesn't take up those extra event loops on the JavaScript thread. Most apps have two types of setup. Either they are a single screen app, which are also called the stacked apps, or a tab based navigation. The choice is totally dependent on what we are looking to build. In this lesson, we'll look at how to set up both of these. The stacked apps also tend to have a side menu or a drawer, and React Native Navigation provides out of the box support for that too. These types of apps are generally called stacked apps because the screens that are navigated to are pushed onto the base screen, creating a sort of stack. The animation on both the platforms are configured to have the familiar native experience. That is, the new screen slides from the right on iOS while it fades in from the bottom on Android. Tab navigation are very popular and are seen on most of the apps. It provides for easy access to different sections of the app from a single location, the tab bar. The boilerplate code starts with a single screen setup. It is called the splash screen in the code, and then it moves to a tab navigation. Now, this kind of setup is great to have some initial marketing screens, or load user data, or ask for login, and then take the user to the main experience. The drawers or the side menu are like partial screens that pop out on top of the current screen from the left or the right, depending on the configuration, not fully covering it. This is very similar to what we have seen traditionally on mobile websites. It can be accessed by either swiping from extreme sides, the left or the right, or we can have an accessible button like a burger menu. So let's jump into the code. And apart from the two navigation setups, we'll also look at using modals. Okay, so let's start the Metro bundler, and we can run it on iOS or Android using the simple code that we have. It's already configured on the scripts, so let's just do yarn iOS. Now if you remember from the navigation index.tsx, we were listening for a launched event, and then we just show the splash screen. Now right now it's just showing a simple screen, as we will see once the app installs and runs. It's already built, so it shouldn't be long. Yeah, and we have our bundler running. Okay, now this is a splash screen. Right now what it does is if we click the button, it takes us to the tab navigation, but let's say we don't want that. We want a stacked app. So the first thing that we need to do is we need to go to the navigation, and then right now it's just a simple screen. We need to tell it that we want to build a stack app. So what we'll do is instead of passing the component directly, we'll say that we want stack, and then as children we'll just pass just pass the component of the splash screen. So id screens dot splash and name. Okay, so now this is a stacked app. Let's go to the splash screen and try and instead of moving to the tab navigation, let's try and move to a different screen. So we'll just call this function, and we'll need the component ID for this. and we can get this from it's available in the props for every screen. So we'll just do navigation dot, since we want to push screen, we'll do push. We have the component ID and we'll just pass what screen we want to see. Now for now I have a dummy screen created. Let's just do that. And okay, it's giving an error because I have not declared it in props, the boon or the bane of TypeScript. And let's just click, yeah. So now as you see what's happening, the screen is being pushed onto the base screen. Now if we move to the second screen and now we push more screens over it, we can see how a stack has been created, right? So that's why this is called a stacked navigation. Now we've directly called the navigation here. I recommend moving all these routings to the router that we created. So what we'll do is I already have a route defined for pushing the dummy screen. So let me just call that from here instead of doing this. So we'll just do router dot show push screen, and it needs the component ID. So we'll pass that. And that should do it. Great. So it also keeps our component really clean, right? So let's add a side menu or a drawer to the screen. So for that, again, we need to go to the route, the navigation, and in root, we need to say that we'll add a side menu. And a side menu will have a left or a right and then a center. So we'll say it's a left, and on the left the component that we want to show. So I've already created a simple screen name drawer. So if we'll go to it, it's nothing. It's a very simple screen, just shows two texts. And let's add the ID, and the left is the drawer, and what do we have in the center? We need to tell it that. So we'll have center, and we can simply copy that. We'll need the entire stack. And if we save, yeah, so it's not visible right now, but if you pull from extreme left, there it is, the drawer menu. Now we can also add an icon to access this. Let's just do that very quickly. Let's go to the splash component and let's add a button. We will add a burger icon, which I have already added to the assets. So there's a burger menu. So let's just do that. It's a simple burger menu image. And pressable is basically the new version of touchable opacity, which basically is we can use to handle any kind of touch events. So what we'll do is we just need to add the on press event to it, and we'll say that we'll call show burger menu. That's a method that we have already declared. So we just do navigation.merge options, and this is the ID that we need to pass. It should be the same as what we declared for the drawer screen. So let me just make it same. Once I save it, it's taking the space, but it's not really visible. That's because the image, we need to pass some kind of a height and width. So let's just call it menu, and let's go and declare height, let's say 44, width, let's say 44, and save it. Oh, we need to save this too, and there it is. It's coming in the center because the container has align center. So let's just put it out of the container. Yeah, that does it. And let's add some space. So that looks better. So we have our image and it should work now. There. Yeah. So that's the side menu, the drawer. The drawer is actually just a screen. We could build anything on top of it. We could build a list of navigation menus. We could build profile, user settings. So yeah, it's very extensible that way. Next, let's look at tab navigation. So if we just go to navigator and index, and instead of doing show splash, let's just call the tab navigation. Now this is a method that we have defined that sets up tab navigation using React Native navigation. It's not something that comes out of the box, and if we just save it, our app now boots into a tab navigation. This is also great, though I do recommend keeping a splash screen and then moving to a tab navigation. The reason for that is sometimes we need to fetch user data from an API or do some kind of loading from async storage or SQLite, and that may take a couple of seconds, which doesn't seem long, but from a user expectation for an app, 2 seconds is a long time. So the splash screen really helps in putting some kind of a placeholder like a GIF or a small video that can keep the user busy and while the data loads, and then we can move to a tab navigation. So if you look at the setup of tab navigation, it's quite similar to what we had for stack. So there's so we are still using a side menu, but let's just, if you could ignore this for a second, there's the bottom tabs, and then it has children, and now each children is actually a stack. So we're just putting 2 tabs right here, like home and settings, and each of them is a stack because on each screen we'll be able to push more screens. So we can push screens onto home tab, push screens onto settings tab. That's why we have a stack, and then it's all very similar to the earlier one. We pass in the component ID. This is default prop. If you want to initialize a screen with store data, we can do that. Or if you want to pass props from a different screen, like when coming back from some screen to a parent screen, we can also do that. And these are some of the options, like the top bar. Do we want it to be visible? Do we want to draw behind it? And these are the bottom tab options that we see. So there's the font size, the text that we want, and the text color that we want. Now, if you would notice, we are using the typography here. We're not using any hard-coded hex strings. And if you want to display an icon, we can pass in the icon. Generally, this is generally 2 sets of icons. One is for home and one is while it's active, that's selected. But we can also do that using these attributes, selected text color or selected icon color, and that ways the tabs will get highlighted with whatever we pass. So like I said, we'll be building an e-commerce app. So let's add a couple more tabs to it. So we can simply copy one of these, and let's say that we'll have a search screen, but for now let's just pass the settings screen because we'll need to add that screen to our views and register it in the navigation, if you remember. So we need to register the screen, so we'll do that. But let's just add 2 more of these and call the third one search, or let's call the second one search, Third one can be, let's say, cart, and we'll have a fourth one for user profile, or let's call it settings, and just save it and reload, and there we have it. So we have a home, search, cart, and settings. So right now they're sharing the screens, but we'll add these screens. So that was easy, right? So we've already seen pushing a screen and it automatically provides a back button. But what if we want to go back manually? How to do that? So this is the dummy screen. Let's just open that. Dummy component. Let's add a button to it. Now we'll be using an element that we've already declared. And it's one of the basic elements. We'll talk about elements and widgets in our design system lesson. But let's just say for now it's a default button that we have configured for our application with some default styling, and the text we passed is shown. So we'll just say title equals go back, and on click we want to call this dot back navigation. So let's just declare that. So we again do navigation. Anything related to navigation is supposed to come from navigation dot. This time we do, last time we did push, now we do pop, and we need to pass the component ID. This component's ID because we want to pop this, right? So now if we do go back, that works. Let's say that we have pushed 3-4 screens on top of this base screen, and we want to come back to not the root screen but probably the screen 1 or screen 2. So how do you do that? So in that case, you just pass the component ID of the screen that we want to move to. So let me just add a couple more screens and come back and show that. So I've added 2 more screens. Let's just call this dummy screen 1, and we will push the screen 2. I've added dummy 2, dummy 3. So let's just push navigation dot push. We'll pass the component ID, comma, component ID screens dot dummy 2, and let's call it push 2, and we need to pass in the name, which is screens dot dummy 2. Save it. So yeah, that pushes dummy 2, but dummy 2 has a go back. Let's just copy this entire thing, go to dummy 2, and let's push 3. So dummy 3, and it probably needs the screen variable and the component ID. So let's just do that. It will push 3. Now we are at 3. Now we want to click this button and we want to go back to the first screen, dummy 1. Now right now it's taking us to 2, but we want to go to 1. So all we need to do is, let's just go to dummy 3, and this is the back one. So we'll just go to navigation, and it has a method called pop2, and this will pass the ID of the first screen, the same ID that we called it with. So it was in home.component, and the component ID that we passed was this one, screens.dummy. So let's just go to 3 and let's just do screens.dummy, save it, and now we have gone back to screen 1. So this way we can control the navigation in a stacked setup. So we can go to, let's look at that again. We go to 3 and from here we go to 1. But what if we wanted to go to the base screen? Let's say that we have completed our journey and we don't really know how many screens are there. We just want to go back to the base one since the journey is done. How to do that? So for that, there's another method that's called pop to root, and it takes the component ID and let's just save it and we're back to the base screen. Next, let's look at switching tabs. Users can always click on these, but what if we want to do that programmatically? Let's say we have a cart icon and when we click on it, we want to go to the cart page. So let's just reuse this push button. So let's go to home component and on show push screen, we're reusing this. We just need to call a navigation method. So let's do navigation dot. We need to use merge options. Now this will take the component ID and we need to tell it that we need to switch to one of the bottom tabs and make the new index as, so it's called current tab index and we want to do it 2 and just save it. So now when we click this, it moves to the cart screen. So we don't need the burger menu here, so I've just added a cart icon and let's just make it cleaner. So the image is on the left. Let's go to the style and let's say align self flex, and now this works because the parent container, the touchable opacity, has a style called cart container and which already has display flex. So it's pretty similar to how CSS works, and that's the beauty of React Native 2. So next, let's on press, let's create a function for this, and so we'll say show cart screen, and we can copy this over here, the component ID, we can just copy it over and we'll say show cart screen, just save it, and on clicking this we are going to the cart page. Okay, so one last thing, let's look at modals. Modals are also components. We can render any screen on it. So let's try that. Let's add another button here and it says show modal and show modal. So let's declare this. So now again, the navigation object, it has a method that's called show modal, and we need to pass something very similar to what we did in navigator. We need to tell what we need to show. So we can say we want to show a stack. Now, as we can see, it supports stack, right? So it's very extensible that way. We can show a single screen, we can show stack. What that means is we can show a modal and then again push screens inside the modal. if the flow asks for it, right? sorry, children will take an array, and then we just pass the component that we want to show. Let's say we want to show screens dot dummy2, and let's click it, and there we have it, our modal. Now since we said that this is a stack, the push and also should still work, right? So that's the beauty of it. And if we look at the animation, this is very native, right? The modals in the native iOS apps, they behave this way. When we push the screen, it slides in, and when we go back, so the animation is all very, very consistent. So let's look at, we saw that we can dismiss the modal by sliding this down, but what if we wanted to do that programmatically? So let's go to dummy2 and do that. Dummy2 component, and instead of the go back, we'll say dismiss modal, and or let's just create a new button. It's quite simple, and let's do it right here. Navigation dot, we have dismiss modal, right? And then we just need to pass the component ID. Just save it, and once we click, the modal is dismissed. So to recap, we saw how to do a stacked app, how to push screens, add a drawer to it, and a drawer is a simple component, a screen, and then how to set up the tab navigation, push screens, go back to a particular screen, and or come back to the base screen, and how to use modals, how to dismiss them. There's just one more option with modals. There's also an overlay. So overlays are actually full screen, so whenever you use it, you have to be careful because it will not have that default option of dismissing it. So let's just do that, and so we need to have some kind of a strategy to go back to the previous screen. And there are a couple of other options with navigation for modals, like there's a dismiss all modals, and there's also a dismiss modals, which we can use if we pass an array of modal that we want to dismiss. And similarly, we have dismiss overlays. So that should cover the navigation of the app. For the purpose of our app, the e-commerce app, will be doing a tab navigation, and we'll continue building on this app.